we are doing techniques for evaluating limits. At the end of this lesson, I will be able to use the dividing out technique to evaluate limits of functions. I will be able to use the rationalizing technique to evaluate the limits of functions. We will be able to approximate limits of functions graphically and numerically. We will evaluate one-sided limits of functions. What do you think a one-sided limit is?
It doesn't work in both directions.
Right, it only works on one side, right? And then lastly, we will evaluate limits of difference quotients from calculus. Who remembers what a difference quotient looks like? Who remembers what a difference quotient looks like? We kind of touched upon it a little bit in the last lesson. We did f of x plus h minus f of x over h.
Yeah.
Difference quotient. And what did this function or this group of functions arranged this way, what did that find for us? Who remembers? I almost hit you with my stylus inadvertently, Riley. Is this mine?
Yes.
Who remembers what that represents? I see. Well, I can see the suspense is killing you, so I'm going to ride that out a little bit longer. First, I want us to consider this function, the limit as x approaches negative 3 of the quantity x squared plus x minus 6 all over x plus 3. And I got a graph here. When I graph this function, it looks just like what function? Yeah, this guy right here, right? Looks like y equals x minus 2. However, when I drill in, when I zoom in on it, I see a hole in the function. Why is there a hole in the function? If I scroll up to the function, why is there a hole in the function? Yeah, I can't have x equals negative 3 here because it makes my denominator equal to 0. Okay? Now, we figured out this looks a lot like the one on our quiz, doesn't it?
Yep.
How did we do this? We looked at the function as it went towards negative 3. Is it negative 3? Yeah, except here, right here. I looked at it as it went to negative 3 from this side, right? And it's approaching what number? Negative 5, right? And then I look at the function as it's approaching negative 3 from this side, and what number is it approaching? Negative 5. So it approaches the same number from both sides. What number is that? Negative 5. So what's the limit as x approaches negative 3? Negative 5. Okay. So we've done this. This was on the quiz. Different equation, right? Different function, but that was on the quiz. I'm going to give you another technique to evaluate this. And we're going to call this the dividing out technique. Okay? So, I give you the same function. Now factor the numerator. Factor this numerator. Remember, it all comes back. We're factoring this guy, right? I don't like that. I like my calligraphy pen. Hold on. In your notes, give everybody a chance. Give everybody a chance. Can you write something down? Even if you guys don't refer to your notes once in your academic career, it helps taking notes. It helps with retention. Hey, write it down.
Oh, no, sir.
Write it down. Yeah. That way you can have your answer and you don't have to share it with the whole class. Everybody can come up with the discovery on their own. Okay. Thank you, Dawson. I don't see Henry doing anything. Go multiply these two out. See if you get. Okay, you're real close. You're real close. Since you guys are having difficulty, I am going to coffeefy my body while you factorize the numerator. So I saw Dawson's answer, and I like Dawson's answer. I liked Logan's answer. Logan was really close, not quite there, but really close. Riley is on point. On point. Josh, let's see what you got. Yes, on point. Kai, yes, sir. Yes, sir. How are we looking, Kai? Very close, very close. Very good. Very good. What do you got? Okay. Close. If you multiply this thing out, what do you get? Hi. All right, so let's walk through factoring, because it occurs to me we should be able to do this in our sleep. In order to find out what makes x squared, this guy and this guy make x squared, right? Yeah. What's the only way I can make x squared? X and x, right? Yeah. Now, this 6 right here, that's a -6, right? So it's going to be what? What's the sign in the sign? Negative, positive. Plus or minus and plus, right? Has to be, right, Kai? Can't get it any other way. Now, if this was positive, I could have plus plus or minus minus, and then which one would I choose?
Depending on what the middle one.
Well, what is the middle one?
Plus.
So it's plus, right? Okay. But this is minus, so it's plus minus. Now, what factors of 6 are there?
1 and 6.
There's 1 and 6 is one set of factors. What's another set of factors? 2 and 3. Which one of those subtracts to be 1? 2 and 3. Is it going to be positive 3, negative 2? Or is it going to be negative 2, positive 3?
Positive 3, negative 2.
Why?
Because that's a positive number.
It's a positive, so it's positive 3, negative 2. Okay? We should be very proficient at that process. Now, what should I be able to just see screaming out at the page at me right now?
You can cancel it out.
I can cancel this out. And this function equals?
2.
Undefined.
What does this function equal? Yes, but no. Does x minus 2 have a hole here? No, it does not. So it simplifies to look like that, but when I simplify, I'm actually losing information, aren't I? I'm losing this hole when I simplify. So how would I keep that? How would I keep that and still honor the function? F of x equals x minus 2, and then I just set my domain for x is not equal to -3. This right here means the same thing as this right here, doesn't it?
Debatably.
Doesn't that mean the same thing? Yeah, because the only difference between this and this here is the hole, right? This takes care of that hole in the function. Does that make sense? Okay. But back to the point. Now that I factored the numerator, I can simplify it. I've done that. And the limit as x approaches -3, what would I do then? Can I use direct substitution at this point? Yes, I would plug in x equals -3. -3 minus 2 is -5. Is that what my graphical approach got me? Yeah? Uh-huh. Does that make sense? All right. Now, dividing it out. First of all, let's see if we can use direct substitution, shall we? Sure. Let's see if we can use direct substitution. So let's plug in x equals 1. So when I plug in 1 right here, I get 1 minus 1, right? Which gets me 0. Here I get 1 cubed is 1 minus 1 squared, which is 1, plus 1 plus 1.
So you get 1/2.
Huh.
Or well, 0 halves. Whoa.
Should it be? I think this is supposed to be a -1. Is that right?
You get a 0.
Who knows?
That's -1. I think I got a typo in here someplace. So -1 cubed is -1. -1 squared is +1, but I'm subtracting it, so that's -1. This would be -1. That still doesn't work, does it? Man. All right, I need to change this function because I want this to break. I want this to be a -1. Let's see. 1 minus 1 is, yeah. So this is my function now.
Okay.
All right? I hate typos. So when I evaluate this denominator, 1 cubed is 1 minus 1 squared, which is 1, plus a -1 plus 1. These are 0. These are 0, right? Okay. Does that make sense, Josh? It's the limit as x approaches 1. But can I direct substitute with the function like this? Because it makes my denominator 0, right? Now, here's the beautiful thing. Because 1 is a 0 of my denominator, what does that mean? What does that say about the expression x minus 1 when I relate it back to the denominator? This is polynomial stuff here that we're talking about. So, x cubed minus x squared minus x plus 1 is going to equal x minus 1, x minus 1 times something. I don't know. Who remembers the remainder theorem? Oh no. Remember, if x equals 1 produces 0 in a polynomial, that means x minus 1 is a factor. It's all connected, right? Everything's connected.
First term's going to be x squared.
So, what do we have to do? We have to take this polynomial right here and divide it by something. What do I divide it by? X minus 1. Do we want to do this synthetically, or do we want to do this the old-fashioned way? All right. X goes into x cubed. How many times? No. 2 times x gets me x cubed. 2 times x gets me x cubed. X squared times, yes. So x, here, let me do this. Move this down here. So x squared times x gets me x cubed. X squared times negative 1 gets me negative x squared. So now I am subtracting, so I distribute the negative. X cubed minus x cubed plus a negative x cubed gets me 0. Negative x squared plus a positive x squared gets me 0. Right. Now, I bring down my negative x plus 1. X goes into negative x how many times? Negative 1 times. Minus 1. Negative 1 times x? Negative x. Negative 1 times negative 1? Plus 1. Fat 0. Let's do it the long way, though. Minus, distribute the negative. Negative x plus positive x, 0. Positive 1 plus a negative 1, 0. So x squared minus 1. So this function right here is the limit as x approaches 1 of x minus 1 divided by the quantity x minus 1 times x squared minus 1. Like that. Who got scared as soon as they saw this? Who got scared? Who thought, oh my goodness, I thought I was done with this? We're never done. Math is a foundational discipline. If I don't know when the Battle of Hastings was, does it matter when I'm learning about World War II?
What's that?
The Battle of Hastings happened in 1066.
In Wisconsin.
Do you think?
Minnesota.
Do you think the Battle of Hastings in 1066, when the Norman conquest of the Britons happened, do you think that matters in World War II?
No.
Now, if you don't know how to divide a polynomial,
Then you're done for the rest of your math career.
it hurts, right? Everything that you learn in math is a foundation for the next thing that you learn. Everything that you learn in math, I'm saying this again, Kai, because it's important, right? Everything that you learn in math is a foundation for the next thing that you learn. Okay? Which is why I've been such a stickler on things like definitions, so we have an efficient means to communicate. And going back and talking about the foundations, how to add, subtract, multiply, and divide fractions. We've gone over that ad nauseum, haven't we? It's because it's important, right? Okay, so now what can I do?
Cancel out the daily do.
I can cancel out, right? Does that help me, though?
Over x squared plus minus.
Not necessarily, right? Not necessarily. Because what do I have? I got 1 over x squared minus 1. And I still have a problem, don't I?
Yeah.
So does dividing out help me out in this particular case? No. So we might still need to go back to things like numerical analysis and graphical analysis in cases like this. Is that clear?
Yes.
Okay. Good. We did that. We did that. Now, I want to rationalize This is another strategy that we've done, or that we're going to learn. It's a strategy called rationalizing. Okay? When we rationalize before, we've done this before, haven't we? What have we always done the rationalizing for? Why have I done it?
Radicals in the denominator?
Yeah. I wanted to get rid of radicals in the denominator. Why do you think I'm doing it here? There's a radical in my numerator, right? So that's the difference. But this process can still help me. What do I want to multiply this fraction by in order to rationalize the numerator?
Square root of x plus 1.
If I multiply this by the square root of x plus 1,
Over square root of x plus 1.
if I multiply this whole fraction by this, what do I get in the numerator?
Negative square root of x plus 1.
I get the negative square root of x plus 1. About I would get square root of x plus 1 squared minus square root of x plus 1. Do I want this guy here?
Square root of x minus 1.
Yeah. Say that again, Henry?
Square root of x minus 1.
No.
Square root of negative x.
Negative square root of x plus 1. Yeah.
That's what I want to multiply by. This is what I want to multiply by. What happens when I multiply both sides by this?
Cancel.
Square root of x plus 1 over square root of x plus 1 plus 1. So, let's multiply these things out. What do I get? What do I get when I multiply the numerators out?
X.
First times first is
X plus 1.
x plus 1. Outer,
Square root of x plus 1.
inner.
Negative square root of x plus 1.
Yeah, so I got a positive square root of x plus 1, and then a negative square root of x plus 1. So those guys cancel out, right? And then lastly, I get negative 1 times positive 1, which is negative 1.
Yeah, x on top.
And then this all cancels or simplifies to just plain x, right? And then I get, in the denominator, I get x times square root of x plus 1 plus 1. And what happens in my fraction then? The x's cancel out, and I'm left with 1 over that hot mess, right?
Yeah.
Now, here, I couldn't evaluate the limit as x approached 0 because I had 0 in my denominator, right? Can I evaluate it now? 1 over, what's x plus 1? What's 0 plus 1? 1. Square root of 1 is 1. Plus 1 is 2. 1 over 2. 1/2. Whoa. You see how that works? Okay. So that's another method of evaluating these guys. Okay? That's going to be all that we're going to talk about today. All right? Because next is the difference quotient. Next is the difference quotient. But I'll give you the assignment, which will be due on Friday. Here's the due on Friday thing. And do I have time to give you the Infinity Hotel thing?
Probably not.